I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll solve one problems by using the Bayes theorem. And first, we'll see the scenario of this problem. So, what is the problem is calculate the probability that an alarm has sounded, but there is neither a burglary or nor an earthquake occurred, and David and Sophia both called the Harry. Now I will tell you and I will explain to you the scenario of this problem. Then only you can able to solve the problem. And you can be asking me one question: who is Harry and why inform him if the alarm alarms off? And in this scenario, Harry is likely the homeowner or house owner. We can call it as home owner, or the person responsible for the security of the house where the alarm is sounded. He is the one who needs to be informed when the alarm goes off because he can take the necessary steps to assess the situation. Whether it is involves calling the police, checking the premises, or disabling a false alarm. While it may not be a compulsion to inform Harry, it is a precautionary action taken by the two fellows, David and Sophia. They are likely neighbors or close friends who are concerned about the security of the house. Informing Harry ensures that if there is a real emergency, the appropriate action can be taken quickly. And another one more question you may be asking: is it necessary to inform Harry? Though it's not mandatory, it is a responsible and sensible action to inform Harry when the alarm sounds. In situations where the cause of alarm is unclear, informing the homeowner or house owner helps verify if there is a real threat or just a false alarm comes on. This kind of vigilance can prevent potential harm or property damage and ensure that necessary steps are taken in a timely manner. This is what about the scenario of this problem. So, in this case, what is the problem is given as calculate the probability that an alarm has sounded, but there is neither a burglary nor an earthquake occurred. Both not happened, but alarm sounded. And so once alarm sounded, this David and Sophia may be informing this Hardy, and how the problem has been given. We'll see. In this case, the solution for this problem is the Bayesian network for the above problem is given below. The network structure is showing the this is the Bayesian structure, and this network structure is showing the burglary and earthquake. See here, this is the burglary and earthquake. These nodes we are calling it as the parent nodes. These two nodes are, we are calling it as the parent node. So we are explaining in terms of node problem, and parent node of the alarm. For what that is for the alarm, these two nodes are the parent node and directly affecting the probability of alarms going off. But David and Sophia calls depends on alarm probability. The network is representing that our assumption to not directly perceive the burglary or and do not notice the minor earthquake, and they also not confer before calling. So in the problem, what is given? Neither burglary nor earthquake occurred. The conditional distribution for each node are given conditional probability table. This conditional probability table, we are calling it as CPT. CPT refers conditional probability table. Each row CPT must be sum of 1 in this case. Each row, the sum is 1, 1, 1, 1. And because all the entries in the table represent an exhaustive set of cases for the variable. In conditional probability table, a Boolean variable with k Boolean parents contain 2k probabilities. Hence, if there are two parents, Then CPT will contain 4 probability values 0, 0, 0, 1, 1, 0, 1, 1, like that. Here we can call it as false, false, true, false, true, true, false, true, true, like that we can say. And in this example, what are all the events we are going to take or parameters we are going to take? Burglary is represented as B, earthquake is represented as E, alarm A, David calls means D, Sophia calls means yes, name. So we'll see the problem. This is the network structure of what I have discussed here, showing this network structure, showing the burglary and earthquake. For this alarm, these two nodes are acting as the parent. And here for each value, they have given the probability value. If the burglary happened, if it is true, the probability is 0.002. And if it is not happening, 1 minus, you know that probability of A is equal to 1 minus probability of A bar. So if you are subtracting 1 minus 0.002, we are getting 998. And earthquake happens, if it is true means 0.001, otherwise 1 minus 0.011 is equal to 0.999. So here David calls alarm. If alarm happens, alarm is sounded off. David may call or Sophia may call. But if you are comparing these two structures, that is burglary and David and all, there is no connectivity. It is being connected, then it is coming to this David call. So here alarm has been running. David calls means if it is true, alarm is running. David calls means probability is 91 percentage. 1 minus this value is the false value. Similarly, if it is false, 0.05 and 1 minus this value is this value. And here Sophia calls, alarm has been running. If it's true, the value is 0.75 and alarm false means Sophia calls, it is true. If it is false means 0.25 and alarm is not happening, it is false. So, and this value is true means 0.02 and false means 1 minus not 2 is equal to 98. By making use of this table, we'll solve the problem. So here, let us observe that the probability for burglary and earthquake components are, if it is true, 0.002 and if it is true, the value is 0.001. And the probability of true is equal to, as I said, burglary. And if it is false means what? 1 minus 0.02 is equal to 0.998, which is the probability of no burglary. Probability of E, earthquake is happening means the value is 0.001. If it is not happening means 1 minus 0.001, we are getting 0.999. So which is the probability that an earthquake not occurred. So in this table is given, what is the problem? David or Sophia may call. What is the condition here? This is the problem. Burglary, neither burglary nor an earthquake means both are not happening. Burglary and earthquake not happening. For that we have to write the answer. So in this problem, so what they have given is Sophia and David calls alarm if one's alarm is sounded, but what is given? No burglary and this earthquake had happened. So in this way, we will be given with many variables. Conditional probability we have to write it. So in the back, from the back will go. So probability of S comma D. Yes, Sophia, David, and alarm comes. It is B bar and A bar means there's no earthquake and no burglary happen. So for this, how we are going to write the equation is, so we are going to write the equation from the back will go probability of B bar into probability of E bar and for given value, uh, for both the cases, probability of A given, that is probability of B and E means once if it is not happening, all at the same time alarm is sounded. So probability of A given B bar comma A bar and probability of what we have to write? We have to write it as a probability of yes. Sophia calls if alarm on. So we'll write it as probability of Sophia S given A into probability of David calls D given A. So here for each value we have to substitute. For each probability we have to substitute the value. Probability of B means what? Burglary happens. So burglary is mean true means 0.002. It is B bar. Probability of B bar is equal to what? 0.998. So you are substituting 0.998. What is the probability of E bar? E bar means earthquake not had happened. So if it is happening means true value not 1. Otherwise 1 minus this value 0.001 false is 999 we are getting. So we are substituting 999. Next probability of A given probability of alarm is sounded, but at the same time both B bar and E bar means that is burglary not happened, earthquake has not happened in this case. So burglary B bar, this is E bar. So what is the value you have to write? For the given alarm is true. Alarm is true. So this value we are going to substitute. One more time I will repeat. Probability of A given B bar comma A bar. Both B bar and A bar for the given value of alarm happening. Here alarm is 2. The value of alarm is A value is true. So we have to write alarm is true. So for this case we have to write this value. So 0.001. Next probability of that is Sophia calls means alarm is running. Sophia is calling. Sophia calling, and if it is true, the value is 75 and 0.075. Similarly, David calls when alarm is running. So the value is 0.91 is equal to 91. And if you are multiplying all those values, we are getting 0.0068045. So it is very simple. So the formula alone you have to write like this. Back from the back we have to go probability of B bar into probability of E bar into probability of A given for what? B bar comma E bar. So means both are neither burglary nor earthquake had happened, but alarm is sounded. So next, int probability of Sophia calls when alarm comes into David calls when alarm is sounded off. So if you are substituting all the values, you are going to get the value is equal to 0.00000068 So hope you understood this problem. Once if you understood this graph, you will be able to easily write the or easily solve the problem. Any type of problem it is coming in this burglary earthquake concept, we can able to solve it. Hope everyone clearly understood this problem. The remaining problems will solve it in the next lecture. Thank you.